Good morning, everyone. As mentioned, I'm a researcher at Sintef, and I will present one of my main projects on reducing fuel consumption of small fishing vessels, a recent project. I'm not sure how much you're aware of the level of the emissions in fishing, but fishing is maybe a small share of emissions globally, especially if you compare it to agriculture and aquaculture. But still, it's about 3% of global fisheries greenhouse gas emissions if you look at the EU emissions of fisheries. And if you want to see what's happened in Norway, it's about the same. So if you look at the total emissions of greenhouse gases in Norway, 3% of it comes from fisheries. And if you're interested in trends, there are different sources of data, but most of them are looking at a bit of increase in recent years. So although it's maybe a small share in the whole picture, but still fisheries are quite dependent on fossil fuel. They are increasingly vulnerable to rising prices and also the demand from customers to reduce the emissions and also from authorities. And also it's a very important part of their costs. And also they are a very important part of the sustainable food system that we have in mind. Especially if you look at different types of food that we have and you get beef as a reference point, you can see how other species are compared to it. So beef is quite high, we have salmon somewhere there, we have shrimp, depending on the type of estimation, going a bit higher and lower than salmon. And this is where capture fisheries are lying. So they are quite some of the greenest type of food that we can get. So they are important for us, but at the same time, we cannot keep increasing their emissions. So there are very many projects focusing on reducing the emissions from fisheries, and one of them is the project that we are involved in. It's a European project and led by Denmark EU Contour, and we are one of the partners. The project objectives are to analyze the need of the fishing communities to define some plans for reducing their emissions. What is important to note is that our project is focused on small fishing vessels. We try to adapt technologies to fit them. We try to test some of these technologies on board and demonstrate how they work. And we validate and calculate sustainability, mainly the economic part of it and also the emission side. Actually, are they reducing emissions? What is the effect of them on the marine life and so on? We also look at how we can take these technologies a step further, looking at business models. And also, of course, we try to have some multi-actor collaboration. So we work tightly with fishermen, for example, and authorities. In the project, we have different work groups, of course. And one of the things that my colleagues do is to look at policy frames that we can define. There are so many regulations in shipping about reducing emissions, but many of them are exempting fishing vessels. But still, we have some few regulations, like the tax system we have in Norway. And we know that regulations gradually get stricter and stricter. But we also know that we have some regulations that make it very difficult to reduce emissions in fisheries. For example, in EU, if a fishing vessel wants to enter the fleet, it means that some other vessels should be taken out because you cannot keep growing the fleet and growing the power and the volume of the vessels. So what happens is that if you want to put, for example, alternative fuels on board, like hydrogen, LNG, we know that these type of fuels get a lot of space on board. So you have to also have in mind what it means for the rest of the fleet. Does it mean that you have to take 2 vessels out to put 1 hydrogen vessel in? But on the, I don't know if we should say it right way, but in one way, we also see that in general, the volume in the fisheries is reducing. So there is a gap. We have some space that maybe can be filled up with this type of fuels. So we have less vessels maybe in a way, and maybe that gap can be covered with some type of fuels that get more space on board. And in this way, we tackle the emission reduction. If you want to, this is not just fishing, it's about the whole shipping sector. I took the graph yesterday, actually, from DNV's app. So you can see that nowadays, actually, in shipping, a very small percentage, is it maybe around 1%, 2%, is alternative fuels. And if you look at fishing vessels, I'm sorry, I didn't know that this screen will be till the bottom, but fishing vessels, around maybe 7 of them or something like that are using alternative fuels today. So this is the type of work that my colleagues are doing. So they look at the regulations, how they are changing, what are the alternatives we have, and actually can be implement them. So if you are interested in this type of work, please feel free to read the report of my colleagues that is actually open access. And they just came in, so they are my colleagues from Spain, that they are the main responsible for this, and they've done a great job. Other type of things that we do in the project, and it's sort of core of the project, is that we have demonstrations on 4 vessels. We have a Norwegian boat, a Danish boat, Estonian, and 1 Swedish. They are all below 12 meters using passive gears, and we are trying to implement mainly 3 type of technologies on them. One is a simul system that I will shortly discuss it, and then hybrid drivetrain and e-coating. So it's mainly to see how this works for the small boats. So this is the simul system. It's sort of a measurement system on board. So you have a tachometer to measure the RPM on the boat. You are getting GPS data. All of these are logged on the PC on board. It's also shown on the monitor to the fisherman a bit about the fuel consumption, and we gather this information. It's sort of nothing new, but it's a sort of cheaper system for fishermen to easier put it on board and gather this data. So it's a system that we think maybe many vessels can use rather than many fancy systems that fishermen with this type of vessel cannot afford. So we put this on all the vessels to see how is their fuel consumption now before implementing the technologies. And after we implement them, we continue collecting data to see how it affects their fuel consumption. So these are the boats. On 2 of these, we are putting parallel hybrid system. The Swedish one is interesting because it's a boat that is not owned by a fisherman, actually. It's going to be a test boat that different fishermen can apply and use it and try it out. So it's a cool thing, I think, if we can do something similar at a point in Norway. So you can try and see how is a hybrid system working, and if you're happy with it, and maybe you consider using it in the future. The Estonian one is a quite old boat that will be refurbished with the serial hybrid drivetrain. And the Norwegian boat is a boat that we will just change the coating of it. Regarding the coating, is the e-coating. It's a sort of a polymer ceramic system that is much smoother, so you will have less algae growth on the boat. If you go fast with the boat, the algae can fall off, but at the same time, we know that it has some difficulties. It is more difficult to apply in the sense that you cannot just take the paintbrush and paint your boat, as many fishermen do. You need somebody that knows how to work with air spray and so on. So we've applied this once on the boat. We had some problems because the curing time, the drying time was not enough, so we're going to try it again with longer drying time. Some other colleagues are looking at the environmental evaluation of these technologies. I just show, for example, the work done on e-coating, but the work is further than this and applies to other technologies. My colleagues at Sintef, for example, apply different types of paint, like the normal coating and this new coating, and they put it in the fjord, and from time to time, they take a sample to see how much was the growth on it. So this is one thing they do. The other thing is that they put these specimens in the lab, and they see how it affects the fish species. For example, if we have an egg in the sea close to this, will it hatch earlier or not? And we've realized that if you put normal coating, you will have hatching earlier, and you will have mortality more. But we haven't seen this with the e-coating. So we see this part as a very positive part of it. Some other colleagues do some, sorry if I just jump from topic to topic, but it's to give you an idea of the things that we do in the project. Some other colleagues look at the underwater radiated noise from the engines and what happens if we put batteries on board and hybrid systems. So they basically run the boat with normal engine. From another boat, they try to measure the underwater noise. And then when we put these new systems on board, they do the measurement again. And they, for example, look at the frequency of noise, and they know how this affects different fish species or mammals and so on. Another part of the work is commercialization. So whatever technology we put on board and we see how it works, we want to go further than the project people and talk to fishermen and see what they think about it. Let's say about the coating, if you were interested, I have some samples I can show you. You can see how it feels, normal coating and the new coating. And we give you some information like, okay, are you happy if you put your boat, for example, instead of 2 days, 5 days in the yard for the coating, but you know that you will need to repaint less frequently, and you will help the marine life. So we discussed this with the fishermen, and we are trying to use this environment to collect this data. So if you were interested in it, please have a chat with us either after the presentation or come to our Sintef booth and we have a chat. Amazing. I didn't think that I will keep time correctly, but I'm more or less done. So thank you so much, and please reach out to us if any of these topics catches your eyes. Thank you so much.